Hello, I am Dipti Vyas from MB Patel Science College, Anand. Now today's my topic is non-parametric test. So before starting with our topic, let us know in statistic what we are doing. In statistic, we are saying that we are collecting the information. Okay, it's well and good. But why we are collecting the information? So here, after collecting the information, we want to draw some conclusion. Okay, so for drawing the conclusion, we are applying test procedure. Now, in applying the test procedure or applying the testing, it helps the statistician to draw the conclusion concerning a population from which or for a population by examining a sample from that population. Here also we say that sample is a representative of the population. It represents the population. So here hence whatever test or procedure we are applying for the samples only. Okay. Also it helps in determining whether observed difference between two samples are due to chance or whether they are significant. So such question helps in determining us, or it helps in deciding whether the two production or whether we can say which production is better or we can compare the two production. So hence the testing procedure helps us in deciding or in the decision theory. Okay. So this you have studied in the earlier section or earlier lecture. So after that, applying test procedure, then next comes that here you are in test procedure, you are applying t-test, z-test, etc. Then in such test, you are saying that the random sample or the assumption followed here that the sample should be normally distributed or the shape of the distribution should be skewed should be symmetrical. Okay. Then if this exists, then we can apply z-test or t-test. Okay. But here then this testing procedure are nothing but we say it as a parametric test as they depend on the parameters. Because here parameters means mean or here we have to calculate mean or proportion or the standard deviation. So in parametric test, the parameters are considered to be the indices. They index the individual distribution with the particular family. આ નથી લાવવાનું અત્યારથી. Most commonly used statistical technique are properly called proper parametric because they involve the estimating or testing the values of parameters. In parametric test, the data of the population from which the samples or a sample are drawn is normally distributed. So here the normally distribution or the data follows the shape of the distribution. Even you are knowing that, or we are knowing that if a random sample selected, then central limit theorem helps or says that for a large sample, these samples follows the normal distribution or the follows the normal property. Okay. Then for sufficiently large sample, then automatically it will be the random samples follows the normal distribution or property of a normal distribution, or the shape of the distribution will be symmetrical. Now if we think as the sky has no limit, we can similarly, if the samples selected or the sample size are small, and then the central limits theorem fails, it does not help us. Okay. Next thing, if the distribution or the data collected or the sample drawn are badly skewed or non-normal, and also then this statistical test will not give us better results. So if the assumption do not hold good, or the data do not meet the requirement of parametric statistical method, then non-parametrics comes to our rescues. So let us start with our non-parametric test. So statistician had devised alternate procedure which can be used to test the test hypothesis about the data which are not normal. And this test does not depend on the shape of the distribution. So here, as they does not depend upon the shape of the distribution, also their parameters are not taken into considerations, so they are called as distribution free test. So sometimes for non-parametric test, it has been said that it is distribution free test. Now from where the idea behind the non-parametric test exists? So here we let us recollect about the order statistic. Now what is the order statistic? Here order statistic is nothing but, here we are ordering the observation. So let x1, x2 up to xn be an observation. And then arrange this observation in an increasing form of magnitude. So x1 will be less than equal to x2, less than equal to up to xn. Then x1 is considered to be the smallest and xn is considered to be the largest observation. Okay. Then this is nothing but the ordered statistic. Now you would be knowing about detailing. We are not going in detail, but here we will apply, or we will take into granted which property of the order statistics helps in the non-parametric test. So here the whole non-parametric test rests on fundamental property of order statistic. This is the distribution of the area under which the density function between any two successive order observation is independent of the form of the density function. So by applying or obtaining the joint probability distribution, marginal distribution, etc., etc., and I have calculated, or we are knowing that the expected area under the density function between two successive ordered observation is given by expectation of ui minus expectation of ui minus 1 is equal to 1 upon n plus 1. So 1 upon n plus 1, no distribution is there. So we can say that it is the independent of the distribution function. Now next comes after the, so whole non-parametric test rests on the order statistic. So in non-parametric test order statistic is applied. So here we are ordering the observation. So suppose you have been knowing, or we are knowing, that the observation are to be ranked. Rank means first is the smallest observation is given a first rank, then second observation, and so on. So here also ordered observation, so order properties had been applied. Okay, now from we should know as a statistician from where the non-parametric test has been started or come to our rescues. So non-parametric test was developed by Harold Hotelling in 1936 while calculating Spearman rank correlation coefficient test. So while calculating rank correlation test, this theory has been arrived, and it was further developed by Wilcoxon in 1945. So from that point, this test has been started. So here let us define the non-parametric test. But if that's, I think so, there's no proper definition, but also I have tried to define the non-parametric test. The non-parametric test is the test that does not depend on the particular form of the basic frequency function from which samples are drawn. Or in other words, non-parametric test does not make any assumption regarding the form of the population. So here, not in a simple sense, we can say that non-parametric test can be applied when the random samples does not follow the normal assumption or the property of the normal distribution. Also, central limits theorem fails. Also, the shape of the distribution are not known. Now, let us know something about let us talk for the introduction of the non-parametric test. So here also, in every test, in parametric test also, there are assumptions associated with as non-parametric test are there. Similarly, what are the assumptions associated with the non-parametric test? So here also, in parametric test, due to the property of the normal distribution, there are much more assumptions are needed. But here, only 4 observations are required. 4 observations, they are just, let us talk one by one. So first observation or first assumption is that sample observation are independent. Okay, it's okay. Second, the variable under study is continuous. Third observation, the probability density function is continuous. So continuous, the samples are also continuous, and the probability density functions is also continuous. And last assumption is lower order moment exists. Okay, so here there are few assumptions related to non-parametric test. So we can say, or it is easy for the non-mathematical person, it is easy to apply non-parametric test rather than the parametric test. Okay, So after seeing the assumption, let us know about the advantage why we are applying non-parametric test. So in non-parametric test, it is readily comprehensible, very simple and easy to apply when the sample size is small. So when sample size is small, it is easy to apply and easy to calculate. Second, no assumption is made about the form of the parent population from which sampling is done. So no assumption is needed about from where the samples are there, or if we are knowing if the lack of information of the parent distribution is there, then also known it's known. Okay, then here next assumption is fewer and less stringent assumption. Okay, fewer and less strict assumption. So no, if the samples are there, no strict rules should be applied. Then they do not require lengthy and laborious calculation. Hence, they are less time consuming. Okay, and then next